In this follow-up video, we're going to look at the question number 7. So this follows after question number 6, and at this point, we know that the rubidium is the limiting reagent. It's the same values of masses of rubidium and mass of magnesium chloride, and the idea is that we're completing a reaction ice table. So the first step in a reaction ice table is to list the amount of each of the reagents before the reaction has happened. So there was a little bit of a calculation that needs to be done here. Verify indeed that you can do this. So I took the 5.004 grams of rubidium and I divided by rubidium's molar mass, and I end up with this amount. Same thing for the magnesium chloride. Of course, before the reaction has started, there are no products, so no magnesium solid, no rubidium chloride. Now remember, if rubidium is the limiting reagent, then it will be completely consumed. And in the end, I won't have any of the rubidium. So of course, this would be a minus value then. And I just need to find the right square to stick in here. Okay, so minus 0.05855. Now by knowing this change, it dictates other things, because the ratio in the change needs to reflect the ratio in the balanced chemical equation. So the fact that we have negative 0.05855, this dictates how much magnesium chloride will be used up. And indeed, if we divide 0.05855 by 2, we'll end up with the 0.2927. Now note, that's just the right number, but there's no negative sign. So this is not the square that I want to put in. So I'm going to drop this back down here and find the negative signed value. So there we go. On the flip side, we know that the amount of magnesium that will be produced will be the same amount, because magnesium chloride reacts with magnesium in a 1-to-1 ratio. In terms of the rubidium chloride, it'll be the same amount as the rubidium lost. So it will be plus 0.05855. So do pay attention to these signs. Note that it's easy then to figure out that the rubidium chloride, the amount will be that 0.05855, and the amount of magnesium that will be produced is this 0.02927. In terms of what is left for the magnesium chloride, so we're going to subtract the 0.02927 from this 0.03620. And the answer for that subtraction is this number right here, 0.00693, paying attention to sig figs. So that's the amount of magnesium chloride that's remaining. So I can pop it into this line right here. In order to calculate the mass, I'm going to take that amount and multiply it by the molar mass of magnesium chloride. And when I do this, I end up with this mass, 0.660. Now, one of the things to reflect on is to make sure that this mass is indeed less than the starting mass of the magnesium chloride. And indeed it is. It doesn't guarantee that the value will be correct, but at least it's consistent. Finally, to determine the mass of magnesium formed, and we've already done this, but just to kind of show you that you can do it based off the ice table, we have 0.002927 mole of magnesium produced. We multiply it by its molar mass, and there indeed is the mass of magnesium produced. I check my response, and we get a green light. I hope this has been helpful in seeing how to complete a reaction ice table where all of the values in here are in moles, and we're looking at the end result, not equilibrium result.